Again, welcome to DSRT 734 class, which is the inferential statistics in decision making. In these lectures, we're going to study about the measure of positions, that's the quartiles, z-score, percentile, and Box-and-Whisker plot. So we're going to learn how to determine the quarters of a data set, determine the interquartile range of a data set, create a Box-and-Whisker plot, interpret other fractals such as percentiles, also determine and interpret the standard score, which we normally call the z-score. Now, determine the quarters of a data set, interquartile. This are the values that will determine or give us the opportunity to measure the positions of our values. So, such as measuring the central tendency, we find the mean median mode to see how the data is varies or the dispersion of the data. We find the range, variance, and also the standard deviation. Now, if we want to measure the positions of our values, like 25 position, what kind of value greater or less than the middle 50 percentile or 75 percentile or any position, then here we can use the percentile or we can use quartiles. Quartiles means 4 parts. So Q1, Q2, again Q3. Also, Box-and-Whisker plot, visually we can see the measure of the position of our values also. So let's start with the definition. What is a fractals? So here we say fractals are numbers that partition or divide an ordered data set into equal parts. So this will lead us to quartiles. So quartiles is a fractals because fractals are data that again are divided, and these data have to be in order. That's, they have to be already sorted in increasing order. So fractals are numbers that partition an ordered data set into equal parts. So the meaning of quartile, we know quartile means 4. So this means quartiles is a fractals, but divided into 4 equal parts. So here we say a quartiles approximately divide an ordered data set into 4 equal parts. So we go through each one, which is, we start with the Q1, which is the first quarter. First quarter will be the 25%. So the first 25% of the values. Are they greater than 60 or less than 60? So about 1/4 of the data fall on or below Q1. Then second quarter. Second quarter is the Q2, which is the middle of the values or the position, the middle position. So we can see that second quarter is not the same as mean. Because remember, in the mean, we had all the value and divide by the number of values. But to look for the second quarter, first of all, our data have to be sorted. Then we look for the middle value. So Q2 or the second quarter is the same as the median, Then we can also find the third quarter, which is the Q3, which will be the 75 position or 3/4 of the data fall. So we have an example here. Here we have a test score for 15 employees enrolled in the CPR training course. And they are listed below. The test scores is 15 listed. Now here they say we should find the first, second, and also the third quartiles of the data set or the test scores. So when we look at this, our data, we can see that they are not sorted from 21 to 7 to 10 to 11. So it's not sorted. They have to be sorted in an increasing order, which means the lowest value comes first before the highest value. So here we can see that the data is sorted now. 5, 7, 9, 10, 11, 13, 14, 15, going all the way is 15. So if it's 15, remember how we find the median. When the total value is a odd number, 15 is a odd number, we're going to get only one middle value. If it's even number, we get 2 middle value. So here we have, since it's 15, we have 7 values to the left, 7 values to the right, So the middle value is 15, and that will give us our Q2. So the next we need to find our Q1. So we can see that on the Q1, we went to the left side. And when we go to the left side, we look for the middle value. The middle value on the left side was 10, Q1, the lower half. Then we go to the upper half. Here also the data value is 7, so it's a odd number. So the lower value is again 18. Now, in some textbooks, what they normally do is that they will add a 15 to the left and also add a 15 to the lower part, to the right and left. But in this textbook, again, we do it separately. So here we say about 1/4 of the employees score 10 or less, which is the Q1, 10 or less, 25, 1/4. And about half score 15 or less, so half is in the middle, 15 or less. Then we say 75% of the students score 18 or less, score 18 or less. So this is our Q1, Q2, Q3. Now, the reason why we use this method, because our value is 15, odd number. So the middle values always will be only 1. Then 15, then we look to the first of all, the data must be sorted. So we go to the lower half to the left, and we look for the middle value. Then we go to the upper half, and also we look for the middle value. So next, we're going to talk about the interquartile range. Interquartile range is the difference between Q1 and Q3. So the formula will be Q3 minus Q1. So interquartile range is Q3 minus Q1. And normally, again, we use it a lot when we are looking for the outline of our data set given. So we are using the first example again. We were able to find Q1 to be 10. I'm talking about the first example here. Q1 was 10, Q2 was 15, Q3 was 18. Now, if they say we should find the interquartile of this data set, it will be 18 minus 10, or Q3 minus Q1. And that's what we should have here. So we have 18 minus 10, Q3 minus Q1. And our score is 8. So next, we plot the Box-and-Whisker plot. Again, Box-and-Whisker plot will let us visually see the position of our data set, the first 25%, the middle, and then 3/4 of the data set. So in order to plot the Box-and-Whisker plot, we need a Q1, Q2, Q3. Then we need a maximum value and the minimum value. So sometimes we use the term, the 5-point summary data for the Box-and-Whisker plot. So here we say we highlight the important features of a data set, and it will require 5-number summary. So we need a minimum entry, Q1, Q2, Q3, and also the maximum entry. So here they say we should find a 5-number summary of the data set. Then we construct a horizontal scale that spans the range of the data. And so then plot the 5 numbers above the horizontal scale. So this is the example here. First, I look at the data set, let's say from 10 to 100. So I can have a horizontal line and scale it from 10 to 100, or from 5 to 105 to leave a little bit space. It's up to us. So the minimum value is beginning. The maximum value will be at the end. Then we have our Q1, Q2, Q3. Remember, even before we find Q1 or Q2 or Q3, we have to sort the data. So the data is in a sorting order. So Q1 will always be less than Q2. Q2 will always be less than Q3. Then the maximum value. Then we draw the box. So the middle box again is the Q2, which is the median. Then starting Q1, then Q3. So let's do the example, the same problem again. Remember, we already find a Q1 to be 10. We find Q2 to be 15. We find Q3 to be 18. when we look at the question, the data set, it starts from 5 to 37. So which means our minimum value will be 5 and the maximum value will be 37. So this is our data set. Minimum is 5, maximum is 37. Q2 was 15, Q3 was 18, Q1 was 10. So we have all the 5 values, and we can again plot our Box-and-Whisker plot. So this will be, so we start from 5 to 37. So 5 is the minimum, 37 is maximum. We draw a line to it. Then we have Q1 should be the first starting of the box. Q2 is always the line inside the box. Then Q3 will be the end of the box. So this will be our box plot. So this helps us to again see the position of the values. So I'll say 75% of the data fall at 18 or below. Only 25% fall at 10 or below. So we also can find the percentile and also other fractals. So it can be if it's 5 or 6 equally divided, like hexagon. If it's 20, it can be any amount. So here we have the quartiles means only 4. So divide data into 4 equal parts. So we get Q1, Q2, Q3. Decimals means 10. So divide the data into 10 equal parts. So you get D1 to D9. Always, we don't want to say the Q4 last. Q4 will be the last value. D10 will be the last value, which we already know. So we only go equally 4 parts, Q1, Q2, Q3. Then percentile means 100. So it will start from 1 to 99. P1, P2, P3, up to P99. So an example given here, we are going to interpret our percentiles. So an OJAV graph is given to us, and they say this graph represents the cumulative frequency distribution for SAT test scores of a college-bound students in a recent year. What test score represents 72nd percentile, and how should you interpret this? So here we look at it and look at the graph. 72nd percentile somewhere here, and then down here we give me somewhere like 1,650 or something. So what we do, we say the 72nd percentile based on the graph is somewhere around 1,700. Again, we have the line. So 72 percentile go all the way 1,700. So this means what? Remember 72nd percentile. So it's 72% of the student had an SAT score at 1,700 or what? Less or less. Because from 600 to 1,700, and that is 72 percentile. This is our percentile vertical line. So this means again, 72% of the student had an SAT score of 1,700 or less. And one more time, we can go through one more. So we have a graph given to us, and the questions based on this graph, this is a data set. The score of SAT, which is horizontal line, and the percent of students who score their score. So for example, if I draw a line from 30 down to here, this means 30% of the students score somewhere around 1,300 or less. But the question said, what test score represents 72? So 72% is somewhere here, and when we draw it down, we find to be 1,700. And that's what we have this line, 72, 1,700. So what the question said, what does this mean? This means that 72% of the students score at 1,700 or less. So next we go through what is a standard score. Again, standard score is also called a z-score. The z-score normally represents the number of standard deviation a given value S fall from the mean. And we may discuss this more detail when we study the normal distribution, where we have one standard deviation is 68.5 and two standard deviation at 5%, and then three standard deviation of every distribution is 99.7%. So this represents a number of standard deviations. Normally, we discuss the three, 1, 2, 3, giving a value S fall from the mean. The standard score for normal distribution, the mean will be at the middle and is symmetry. Now, to find the z-score, always is the value of the z-score you are looking for minus the mean of the data set divided by the standard deviation of the data set. So it will be x minus mu over standard deviation. So a question is given here. They say in 2007, Forrest Whitaker won the Best Actor Oscar at age 45 for his role in the movie The Last King of Scotland. Now, Erin Murray won the Best Actress Oscar at the age 61 for her role in The Queen. The mean age of all the Best Actor winners is 43.7 with a standard deviation of 8.8. Now, the mean age of all the Best Actress winners is 36 with a standard deviation of 11.5. Now, the question says, find the z-score that corresponds to the age for each actor and also the actress. Then compare your results. So this means since we know Forrest Whitaker is 45, the average age was 43.7. So it will be 45 minus 43.7. And the standard deviation for the men is 8.8. So we get 45 minus 43.7 over 88. And the answer will be a positive value, which means Forrest Whitaker is older than almost the average age of the best actors role, best actor winners. So let's see the result. So Forrest Whitaker, we say z equal to x minus mu over the standard deviation. S will be Forrest Whitaker age. The mu is the average age for all the actors for the winning category, and then the standard deviation of all the actors for the winning category. So we get 45 minus 43.7 over 8.8, and that gives us 0.15. Now for Ellen Merren, the same thing, age, which will be x, the mean of actress, and also the standard deviation of all the actresses also. So her age was 61, the mean is 36, and then standard deviation is 11.5. So which gives us 2.17. So 2.17 standard deviation above the mean, and this is also 0.14 standard deviation above the mean. Why is it above the mean? Because the standard deviation value is positive. When the standard deviation value is negative, it means the mean is greater than the value. So now comparing z-score from different data sets, they said if the z-score corresponding to the age of Erin Murray is more than 2 standard deviation from the mean, so it is considered unusual. Now, compared to other best actress winners, she is relatively older, whereas the age of Forrest Whitaker is only slightly higher than the average age of other best actors. So again, when we see our result here, we can see that the z-score for Erin Murray is 2.17, which means she's older than average, a little bit more older than the average age of all the actresses. But we can see that Forrest Whitaker is almost close to 0. 0.15 means Forrest Whitaker age is close to the average age of all the actors. If it's a negative value, then we say for us, win taker is way younger than the average age of all the actors. So this will be the conclusion of our lectures on how to measure positions of a data set. Again, finding the quarters, Q1, Q2, Q3, and also the concept of a Z-score. And again, wish everybody the best. Thank you.